So yeah, as the program said, my name is Tyler Clark. I'm a software engineer for Pluralsight, which is a subscription-based online learning company that has a lot of videos online for developers, creative people, front-end, back-end database stuff. I do have some free 1-month trial cards for Pluralsight. If anyone wants to check out some of the content, just find me afterwards and I can give you one of those. Today I'm going to be going over a lot of stuff, and so it might feel like a lot. So I'm going to be posting my slides to my Twitter account later today. So if you want to go back over them and review what I talked about, you can follow me there. And I've also got some articles on Medium as well. If you look at that, my handle is Tyler W. Clark on there. So I want to just get an idea. Has anyone used Redux Sagas before, maybe in your app? Okay. Okay, we got some people. What about Redux Thunk? All right, that's what I guessed. Just before I move on, I want to give just a general statement to anyone that's like, what the heck is Redux Saga? Well, it's a Redux middleware that does the same functionality as Thunk, but the way that it does it makes it a little bit more efficient to use, easier to test, better at handling failures. So I broke down my talk today in 4 main sections. I want to talk about sagas in general, move into the ES6 generator, talk about how we use that inside Saga and why that's critical. And then we'll work through a basic implementation of Saga and then move into testing. So just like any great talk, it's important to understand the why behind it. Why am I even talking about it? Why should you take the time to look into it? What makes it worthwhile? Well, I've got three bullet points that, to me, stand out the most for Redux Saga. For you Thunk users, this one probably stands out to you the most. The first one is you escape the callback hell, and we're going to take a look at some examples of that. The way that Saga handles the side effects, we do that in a way that's super easy to use. We can run parallel and cancel side effects as they're running, even current in-flight requests. You can make channels or queues of side effects. And then lastly is testing. And I'm not talking about making mocks of your response from your endpoints. I mean actually testing to make sure your side effects are doing what you wanted to do at the right time. And I've asked about Thunk and talked about Thunk a couple times because when I first started using Redux, I went to Thunk too. Just from side projects to actually enterprise code, I was using Thunk for everything. And just like all the hands in here, everyone else pretty much uses Thunk as well. As you can see from NPM, they're pretty popular. So I want to take a second just to talk about a Thunk. For those that maybe don't know what that is, just a kind of idea so we can compare Thunks to Sagas. Well, here's a basic Thunk. Thunk basically just comes in and modifies your Redux action creators. Instead of returning objects, we're returning functions. And that returned function gets the store dispatch method. And inside that returned function, you can do whatever you need to do. In this case, it's a timeout, and we're dispatching an action creator inside of it. Well, as we all know, our applications are not this simple, and we need to start scaling them. And so our basic Thunks become a little bit more advanced, where we're returning a function that's doing more stuff. And so in this case, we've got, we're transferring money, and obviously when you want to transfer money from one bank to another bank, there's obviously a set of steps you need to do before you do that, where you want to make sure there's a balance in there. Then once you've confirmed there's balance, you want to make sure that the friends account exists, that the settings are checked, and then you can make some notifications, and then finally, the bottom there, move money. And the way that you handle this in Thunk is you get into this promise, callback, chaining pattern, where you wait for a promise to resolve before you move on to the next promise. And this is so you can do asynchronous things synchronously. And as you can see here, we're starting to get a little more complex. We've got these .thens we're chaining. We've got 4 or 5 functions in this one method. And then this example I got from Redux Thunk's GitHub, and making sandwiches for everyone where we're doing a whole bunch of stuff. We're returning function after function. We're chaining promises one after another. We're dispatching all kinds of stuff with logic. And again, this is just one action creator. This is one action creator that you're wiring up your Redux Connect that's going to be called from your component level that's doing all these things. And you can imagine if anything breaks inside of your callbacks in here, how difficult it would be to manage your errors, trying to dig through your call stack to figure out where the error happened. And not to mention, if you even try to test something like that, what would that look like? Well, it'd probably be just a lot of mocking, and most of your tests would take longer to figure out and work through than actually making your thunk. And so that's where Saga comes in and really makes a big difference of how we handle those. So here's some bullet points really quick. The difference between Saga and Thunk. Well, as we saw, Thunk, we're modifying our action creators. These are the action creators that go along with your Redux Connect method, that go along to your props, your component level. It's injecting itself into those action creators. Works on a promise basis to make sure your async stuff happens synchronously. And it's pretty easy to get started. You just install the middleware, and you can return a function and do whatever you need to do in there. And it's on that function callback pattern. Well, Sagas comes in, and it's completely different. It itself is independent of your action creators. You can call action creators from inside your Sagas, but it doesn't go through the Redux Connect method down to your component levels like Thunk and regular action creators do. It's more of a daemon or a background running process that you can use. It has its own built-in commands that we organize our side effects with. There's a little bit more of a learning curve with it if you're not familiar with generators, and just learning those commands might take a bit longer than using Thunk does. But once you get a hang of it, then it's not too difficult. And I want to kind of give everyone a basis of generator functions. Probably not used very much in prod code. I use them a lot in Sagas, but I want to give everybody just a little refresher or intro to generator functions because Sagas are built on them. And with generators, if you use them correctly, they can mimic that chaining promise behavior. Where, again, remember with Thunk, the way that they handle asynchronous things synchronously is by chaining promises one after another. Well, with generators, you can break up your side effects into individual iterations. And so you organize your side effects. You can do an iteration, and then you can pause. You can do another iteration. You can pause. So you can break up your side effects. And the way that you step through this function, you can wait for as long as you need to before you step to that next iteration. Now, with generators, first you start out with defining a generator function. Well, you use the star or the asterisk right after the function keyword. And when you invoke a generator function, it doesn't return your return value that you've given it. The regular functions, if you don't give it a return, it's undefined. If you give it a 1, it returns a 1 when you invoke a function. Well, with generators, regardless of that return value, it's always going to return a generator object. And this generator object is broken up into sets of iterations, something like an array iteration or a string you can iterate over. And the iterations from the generator object are defined by the use of the yield keyword inside of your generator function. And then the way that you iterate on that returned generator object is by using the .next to iterate over them. And when you use the .next on that return generator object, then you get a returned object with two properties, value and done. Value is going to be whatever was defined to the right of the yield keyword inside your generator function. And then done is telling the executor if that's the last iteration inside of your iteration of your generator object. So let's look at some code for this. I notice I'm only ever walking over there, so I'll look over here too, so everyone doesn't feel left out. So we've got an example here, generator function. We know that. It's defined with the star or the asterisk right next to the function keyword. We're passing in a parameter. We've got two iterations in our function, two yields, I plus 1, I plus 2. The next line, we're assigning the returned generator object to the variable gen, passing in 1. Now gen becomes that generator object, we have the power to .next through the iterations that we've defined in our function. So the first two times we console.log, we're going to get 2 and 3. The third time, well, there's only two yields, there's only two iterations, and so it's going to be undefined. There's no more left. And if we were to do a done, it would be true on that last one and false on the first one, telling us if that was the last iteration or not. And so the gen, once we have this return generator object, we have the power to decide whether we want to step through to to that next iteration or not. We can wrap it in a set timeout, so we can say, all right, generate object, before we step to that next iteration, let's wait 10 seconds, and then step and call that yield. And so we can organize our side effects where we can wait for one to resolve or not. So how does that play into Redux Saga? Well, with Redux Saga developers, we make our side effects into generator functions. And we list every side effect, whether you're just using an AJAX function, we're hitting the browser, the ES6 fetch. We organize them with the yield keywords, so they're to the right of our yield keywords. And then once we make these functions, we pass it along to the Saga middleware, which becomes that the gen, in this case, the my generator, that it takes those return generator objects and then steps through them for us. But there's a problem. How does our Saga middleware know when we want to wait for one of our side effects to return to use probably later on in our function? When does it know when we need the return response, and not to just step through those iterations really quickly and leave us stranded with an undefined because we're waiting for a promise to resolve? Well, we do that by using the commands that come built in with Saga. And these commands are also called effects. They've got two silos. They're either considered blocking or non-blocking commands. And so we can do whatever side effects we need, whether it's, again, an AJAX function, hitting the browser, whatever it needs to be. We just need to wrap our side effects inside of these commands so that we can tell Saga middleware, which is the iterator, which is going to step through those iterations that we've defined, whether to block the iterations or to non-block them. A blocking command is basically saying, all right, Saga middleware, do this side effect, but since I've wrapped it with a blocking command, I want you to wait for the response to come back before you step through to that next iteration that I've defined in my Saga. While on the other hand, non-blocking, let's say you wanted to hit an endpoint just to keep track of your user and you don't really care about a response from your backend. So we wrap our side effect in a non-blocking call, and it just calls it and moves on, so we can be efficient there. We can cancel those at any time, which is pretty cool. Let's say you've called off a non-blocking call, but you've stepped through a couple iterations. There's ways that you can go back and cancel them if something has happened. And we get some special testing utils from Saga to test them. So let's walk through an example so you can see some code using actually putting this to test. So let's write an example. Let's do two things. First, let's do a side effect that hits an endpoint. In this case, we're going to use the Star Wars API, the SWAPI, free Star Wars API. And then once we get that response back from the Star Wars API, we want to dispatch an action with that response data to our store so that our reducers pick it up and goes to our UI. And so since we want the response back from our Star Wars API, we need to make sure we wrap our side effect with a blocking call, and then dispatching an action, we don't really care for a response, so go ahead and fire that and move on. So for our blocking effect, we're going to use call, which is built into Saga. It's got two parameters here. The first function is going to be our actual side effect AJAX function, where we're going to actually go and hit the endpoint. And then the second argument is going to be just our string URL. Those get passed into that first provided function. And then put is kind of built into Saga that does the exact same thing as the store dispatch method does. And so we can just give it an object, and that's what's going to be dispatched to our store. So here's our example. As you can see, the first thing we need to do is bring in those two commands: call, blocking effect, put, the store dispatch. Now we can actually make our side effect function. Again, it could be hitting your browser, whatever side effect you need to get done. In this case, we're just going to use the ES6 fetch and the provided URL to go and hit the API and then unwrap that promise. Next, we're going to actually make our first Saga. So here you go. This is your first generator Saga. You can see if this is new to you. We know it's a generator function. We've got that star asterisk right next to the function keyword. We've called it fetch people, and we wrapped it in a try catch so that we can capture any errors from hitting the Star Wars API. We can console log those out or do whatever we need to. But that first step, you can see we're doing a yield call. So yield to break up our iteration, call to block our generator so that we can make sure we get that response back and assign it to the person. And then we pass in our side effect with that Star Wars API. And then once that call has resolved and we've gotten a response back, Saga middleware, okay, let's move on to the next iteration, which is yield put. And this is where we're going to dispatch an action with, you can see at the very end there, we've got data and person results referencing our response back from our Star Wars API. So now we've got our Saga. It's doing what we want it to do. It's calling, it's putting, it's blocking, it's non-blocking. We're doing our side effect. This is all great. However, how do we actually run this from our app? So we've got it, it works, but how does it get called? Well, our regular action creators, Thunk included, and action creators in general, typically you'll use Redux Connect and pass it along to your components, and then they'll be invoked when you press on that you call this action creator. However, with generators, if you remember, we can't just invoke a generator because it returns a generator object. It doesn't actually do the stuff that you defined inside of it. So it doesn't really do us any good to pass the generator function down to your component level and have that be clicked on. You need something else going on. Well, what does actually happen is action creators, regular ones, if you look at this one, this fetch Star Wars request, we can pass this one down to our component level, and when you click on the load more button, it dispatches it to our store. And because Saga middleware is a middleware, we have access to the actions that have been dispatched. And so how Saga middleware knows to call our Sagas is it uses some type of connect config generator, where we import our fetch people Saga, that's doing our two things, put and call, and we connect that with the connect generator, where we say, all right, Saga middleware, whenever you see this type that's been dispatched by a regular action creator, that's when we want you to spin up the Saga and start doing the things that I've listed inside my generator function. And so these connect generators will take in your action types in your Sagas and organize it with something called a Saga helper, which is a method from Redux Saga that does, and you can use one of the two things here, take every or take latest. Take every says, every time we see an action dispatch to the store with the provided type, we're going to spin up a new Saga that we've given it concurrently. And so if someone was sitting there clicking that load more button, dispatching that one regular action creator, Saga would just start iterating through new instances of the provided Saga. Or there's take latest, where it says, if there's one that's already running, when we see a dispatched action that matches the pattern, then cancel it, wherever it's at, spin up a new one, so there's only one, or the latest, running at a time. And so this is some code for what that connect, and I'm just giving quotes here. That's not actually what it's called. There's no really name for it. I'm just calling it a connect or config generator here. So we need to bring in that Saga helper method, take latest. And then we need to bring in our Saga that's doing that call and put, fetch people from our actions. And then we wired it up with that take latest inside this Saga connect. This is where we're saying, all right, the first parameter is the type. We want the Redux store to listen for, our middleware to be watching for dispatch actions, that fetch Star Wars request, just the regular action creator. And once it sees that, start spinning up fetch people, that Saga that we're doing those two things. All right, so now that we've got our Saga, it's doing our side effects, we've got a connect method that's telling our middleware when to fire our Sagas. Now let's actually wire it up with our store and our middleware. So you can see we're going to bring that Saga connect over to our middleware, and installing Redux Saga is just like any other middleware in Redux. Inside of our store, we're going to bring in apply middleware. From Redux, we're going to import that Saga connect from our Sagas file, and then apply middleware with our Saga middleware. The last step is Saga middleware.run. This is how we basically turn on Saga middleware, and we're passing through that connect that has our Saga that's doing our side effects and the type that we're telling it to do. And so this is where that connect generator gets passed through to the middleware, where the middleware takes and says, all right, I'm listening for this action type. When I see it, I'm going to start up this provided Saga. Let's recap this and get some bullet points here so it's easier to recap. Our Sagas, they're just generators. They're not regular functions, callback functions that can make you lose your sanity just as your application grows. You can do whatever side effects you need to do. Just remember to wrap them in effect commands so that your Saga middleware knows what you want them to do with it. and then the yield keyword, so it's broken up into iterations. We have some kind of connect or config gen that tells the Saga middleware when exactly we want it to start running the Saga that we've given it, and just wire it up with the store, like any other middleware. And if you remember our no idea Redux Thunk, where we're apparently making sandwiches for everybody, but we're doing a whole bunch of crap in here with return functions left and right, we could do something similar to this with our Redux Saga, where we're making sandwiches for everybody, and we've wrapped it in a try-catch to handle our errors gracefully, and we've broken up our calls into what looks like a synchronous pattern, where we can do our blocking effects call one after another and just break it up into iterations. There's no nesting or closures. It's just one call after another, just followed by the yield keyword, and to step through it. It's much easier pattern to see. And that leads me to the next part of this. Since we've got these iterations, we're just using a generator function. Guess what? We can test them. We don't have to mock out our closure callback functions. We actually have the ability to test and make sure that, hey, at the right iteration of our generator, at the right time, it's being called with the right command with the right parameters. And lucky for us, the effects, the commands that we use from Redux Saga, like call, actually will return an object. So when we wrap our side effects inside of these commands, the response from invoking call is a returned object. And this returned object gets passed along to our middleware, and the middleware reads it. And since it's just an object that's been returned, we can just do a recursive check inside of our tests to make sure that the right command is called with the right information. So that's the deep equal in Mocha and Chai, or the to equal in Jest. And we could replicate different situations our Saga might experience by using the .next. And also, the yield keyword, not only does it define the iterations and define what the return on the iteration is going to be, but it itself can also inherit values from the executor. So again, we've got a generator function. It's going to have 2 because there's code before the yield in this case. And so when we .next, we're going to get 0. We .next passing in a string pretzel. Yield is going to accept that pass-through value, and it's going to yield out 1 pretzel for that second console log, which is neat and also really helpful because as we test our sagas, we can pass through different data and make sure that our sagas handle that. So if you've got some kind of if check or bool logic where we want to say, hey, if our response from this endpoint is this data, then do this, well, guess what? We can pass through mocked data to our generator sagas and make sure that they do what we want it to do with that returned data. And so here's this is that saga example that we created. We're doing the call put, the fetch people, and this is what we're going to test. We want to make sure that it calls and then that it puts. And so the way that we'll do that here is first we need to bring in the effects that we used. We've used call and put, so we'll bring this into our testing file. Then we need to bring in fetch people and the API function that we made. Fetch people is that Saga. Next, we're going to do what the Saga middleware does for us, but we're going to replicate it. We're going to get that return generator object, assign it to gen, and then we're going to iterate on our Saga. So in this case, that first iteration, if you remember, was the call. And so we can say on that first iteration, get the value, and then to equal, recursively check to make sure that that side effect was called with the call command, first off, and then it used the API function with this provided string URL. So there's no more mocking. We don't have to make up some response from our endpoint. We can just make sure that our commands are being called on the right iteration of our function with the right data. And then our second iteration was the put. And so again, we do the .next on our generator object, which takes us to that second iteration. We give it some data. Then we make sure, you can tell at the bottom that we make sure that our action type is in the same format, where it's doing data, person.results, it's recursively checking the put, and this is just the beginning of a test. I mean, generators, they have, you can throw on them, the prototype method throw, so you can even test to make sure that your catch block is doing what you need it to do. You can replicate your Saga failing, and at Pluralsight, we've got a whole bunch of commands that we do inside the catch block to make sure that if we get something failing, we can show something to the user and say, hey, sorry, something happened. And so we can actually write tests. If in the case that our side effects fail, we can test and make sure that they're doing what they would need to do. So let's recap this. Testing our sagas, we import our use saga effects into our testing file and the saga that we want to test. Our object effects, there are commands that we use. When we invoke them with the provided parameters, they just return objects, and we can recursively check and make sure that everything was used correctly. Now I've only used two effects here, call and put, one blocking, one non-blocking. But Redux Saga has a ton of functionality to it. We use at Pluralsight, we use a ton of more advanced topics to use. Unfortunately, there's just not enough time in my talk to go over them. So I definitely challenge you to take some time, look through some of these blocking and non-blocking effects, these queuing up, these channels, handling cancels. Generators give us the ability to make separate generators and pass them through to your one saga, so you can kind of section off your side effects into other side effects to use. There really is just tons. And there's other testing utils that Saga gives us to test these more complex side effects. And so there's built-in testing utils and tons of stuff. So definitely take the time, check out the Redux docs, the Redux Saga docs, and play around it for yourself. Thanks.